This is the part 3 of our software development lifecycle video series. So in the previous recordings, we discussed the first two phases of SDLC, which is the preliminary investigation and the system analysis or system study. So today, in this session, we are going to discuss about the third phase of SDLC, which is the system design. So the purpose of this design phase is to plan a solution for the problems identified in the analysis phase. So in the analysis phase, you try to identify what are the problems in the existing system and what are the things that the user required from the new system. And in this phase, we are trying to identify, or we are trying to describe how the system will fulfill the user requirements. And the output of this stage will describe a new system as a collection of modules or subsystems. So when talking about the designing activity, when talking about the designing activity, this design activity is divided into two phases: logical design and the physical design. Logical design is the part of a designing phase that is independent of any specific hardware or software platform. So if you're doing the logical design of your system, you can fully concentrate on the logic of how you're going to satisfy the user requirement rather than thinking of any hardware, software specific information. So for you to do the logical design, you should not be capable of any specific technological details. So you should be strong enough of logical thinking, but it's not a big requirement for you to know any specific technological details. Whereas physical design is a part of the designing phase where the logical specifications are transformed into technology specific details. So if you are going to convert your logical design to your physical design, you have to think of, okay, what are the programming languages, or what are the database management systems that you're going to use? So the technology specific data. So it's a part of the designing phase where your logical specifications are transforming to technology specific details. Okay, let me explain this logical and physical design using designing the database table employee. So let's see what's the logical design. When you're doing the logical design, you don't have to worry about what is the database management system that you're going to use, what are the data types used in different database management systems. Only thing is you need to logically think for this employee table, what are the fields that you need to have, and what are the data types that you're going to use, and the data size of each field. Now, say for example, we decide, okay, in the employee, this is just a small example, not the correct exact employee table. So say you need to have the employee number, which is going to be your primary key field. So it's going to be a number. It should be a numeric field, which is auto-generated number, for example, increase by for the next employee. And the employee first name, it is a character field, last name a character field, date of birth should be in the date format, and the employee basic salary, it should be a fractional number where a number followed by 2 decimal places, and the status, the employee's active status, whether active or inactive, or a current employee or a retired employee. So you can either use 0 or 1 or yes or no, Y or N. So here we have decided, okay, we are going to have a character and it's only 1. So if it is yes, Y, if it is no, N, like that. So for the logical design, this, of course, you don't need to think of any database management system, only you have to logically think what are the fields that you need in your employee table, and what are the data types, whether this is a numeric field or a character field, or if it is a number, whether it's a whole number or a fractional number, and the size, how many digits that you're going to have in this field. So this you can do using a piece of paper and a pen, or in a Word document. It's very, like, it does not require any specific technological details. Only thing is you have to logically think how the table should be, what are the fields that this table should include. Now we are going to convert this logical design into its physical design. When converting this logical design into its physical design, you have to now think of what is the database management system that we are going to use to design this database. So whether you are going to have an Access database, whether you are going to have a SQL database or an Oracle database, so you need to think of a database management system. Say, assume, okay, I'm going to have my database. I'm going to have an Access database. So you are going to design this table in Access. So if you're designing this table in Access, you should know Access. You should know what are the data types used in Access. What are the lengths of each data type? How these data types work. So you have to have this technical knowledge, without which you cannot do your physical design. Now this is the example of the Access database. So you should know how to use Access, and how to give these names and the validations. And once you specify, say this is employee number, it's an auto number, so it's an auto generated number for each field. And the first name, it's a short text. If you use long text, what is the size of that? So everything you should know. If it is only, say we have selected only 5 in only 10 characters, so if it is only 10 characters, we can use short text rather than using long text. So you should know these things. Without knowing, you can specify the data type. So it is hardware, software specific information in the physical design. Hope you understand clearly what is logical design and what is physical design. In logical design, it's hardware, software independent. You have to fully concentrate on the logic of your design. And in the physical design, it's the part of the designing phase that is hardware, software dependent. So with that, let's discuss what are the list of activities that you basically do in the system designing phase. Now, for all these activities that I'm going to discuss in this slide, I'm going to have separate videos for each of these activities, how to do these things. But here I will just list down what are the activities that you do in the system design phase. So you have to define the output requirements. All the outputs from your system you have to design. So this can be reports, mainly it is reports and output messages, invoices, anything that you generate from your system, you need to define. So this defining output requirements include, you have to decide on the volume, frequency, format, and distribution. Volume means how many records that you are going to have in your output. Frequency means how often you are going to get this output. Format means the layout of your output. You have to design the layout of your output. And the distribution means to whom you are going to give this. And also you need to specify the input layouts and the frequency of use. Like this is basically the screen design. So I'm going to have a separate video on these things, how we are going to do this. And the third one, determine controls and checkpoints. So what are the security measures, how you are going to protect your information system, and what are the points, what are the checkpoints, everything you need to decide in this system designing phase. And also you need to identify the database tables and their characteristics, as we did in the example. So you'll be doing the logical design as well as you'll be converting your logical design into the physical design. And also you need to prepare the program specifications for each and identify the programs. You need to build the logic, how we are going to achieve this task. So this is, you can use pseudocodes, you can use flow charts. You have to build the logic, and you need to test the requirements. You have to develop the test requirements and test data. So what are the areas to be tested in this system, and what are the test data that you are going to use to test the identified areas? All these things you decide in your system designing phase. So it is a very, very important phase in SDLC. So with that, now we can move on to the objectives of this system. So when talking about the objectives of the system design, the aim of this system design phase is to prepare a comprehensive plan to deliver the user requirements, to prepare a comprehensive plan to satisfy the user. So while preparing a comprehensive plan to deliver the user requirements, there are 3 other objectives that you need to consider: performance, control, and changeability. What is performance? Performance is how fast the design will be able to do its given task. Control is extent to which the system is secured against human errors, machine malfunctions, and mischiefs. Changeability is the ease of which the design allows the system to be changed in future requirement changes. So if I explain this with a very small example, say a customer asks you to develop a system to accept 5 numbers and to output the total of those 5 numbers. So your aim, main purpose, this system should accept the 5 numbers and should give the total. So if it is not there, no point. So the aim of the design is you have to design your system to give this functionality. So while giving this functionality, other 3 objectives that you need to consider: performance. So once you give the 5 numbers, if your system takes 1 hour's time to give the output, so there is a performance issue. Will the user satisfy? No. So you have to consider that factor. And then the control. And say the user says, it's only me should do this, not anybody else. Anybody else should not access this system, should not allow to enter the numbers, should not allow to get the sum. So how you are going to protect your information system, how you are going to avoid any other accessing this system, you have to think of the control. And the changeability. Say later on, this customer might ask, okay, not only 5 numbers, now I need to get 100 numbers or unlimited numbers. So depending on the number of numbers that I entered, the system should get me the sum. Or I need to have not only with the sum function, I need to get the average as well. So in this type of a requirement change, if the user has requested, do you need to change or the entire system? Do you need to do this small change? Say user has now asked you to get the 100 numbers, not only 5 numbers. So to give 100 numbers, do you need to prepare a new system starting from the beginning? Or can you do a simple change, a small modification to your existing system and give it? What is best? It should be able to easily change, easily modify. So these factors you need to think when you design your information system. So when you're designing Mainly when you do your logical design, you don't need to think of hardware, software specific factors, but you need to think of these factors. How I'm going to increase the performance, how I'm going to increase the changeability. These things you need to think when you do your logical design mainly, right? So before winding up, let's go for a quick brush up, multiple choice question. A part of the design phase that is independent of any specific hardware or software platform is known as logical design, physical design, software design, none of the above. What do you think? It's known as the logical design. Is not an objective of system design. Performance, control, changeability, observation. What is not an objective of system design? Observation is not an objective of system design. So mainly in this video, we have discussed about the system designing phase. So after system designing, what is the next phase in SDLC? Fourth phase in SDLC. So the next phase in SDLC is the software development. So once you're done with your design, now the goal of this coding phase is to translate the design of the system into code in a given programming language. So now you have the design, you know what to do, and you know how to do, and now you're transforming this into a computer program. Say if you have your pseudocode, if you have your flow chart, now using a specific programming language, you are going to write the coding, you are going to build your information system. So with that, I can wind up this part 3 of software development life cycle video series, and in the next one we are going to discuss the next phase of SDLC. So after software development, what is the next phase? Is the software testing. So let's see, in another video we'll discuss about software testing. Thank you for listening.